It's a lovely weather today. It has rained a lot, and there is a power outage in my area. So to save some of the bandwidth, I'm not starting my video. I'll start my video as soon as the power is available. So we are going to use, because I'm using my cell phone data, so I'll be conserving that cell phone data maximum to give you the slides and the knowledge. All right, so I welcome you all to fourth masterclass. We have been in this journey together for the last 6 hours, right? So we had 2 hours of masterclass each. It extended more than 2 hours, so we have been together for the last 6 to 7 hours, and we have learned a lot of basics. Today is the first masterclass that we are going to learn something concrete. That means that we are going to learn a transferable skill. We're going to learn programming, and we are going to do a simple program in Python to emulate machine learning. All right, so we have learned in our previous masterclass about machine learning. Machine learning is a branch of artificial intelligence and computer science that focuses on using data and algorithms to enable AI to imitate the way humans learn, gradually improving its accuracy. So I was talking about machine learning in my first masterclass. If you remember, we were talking about the three differences between artificial intelligence, machine learning, and deep learning. And machine learning is a way of achieving artificial intelligence, right? So artificial intelligence is that broader concept which talks about making machines intelligent in a way that they do the similar things, similar tasks that human can do, like perceiving, like classifying, like reasoning, and learning. So we are designing all these artificial intelligence agents, and one of the method is by using machine learning. And machine learning is a branch of AI and CS that focuses on data and algorithms. So basically, we have a lot of data in our kitty, and that we use to train our models. And by using these algorithms, we predict or classify something. To jot your memory, I'm going to just clarify one concept that we learned in Masterclass 1, that there are three types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. So supervised learning, we were doing it on data which was labeled if it was a table. Unsupervised learning, we do it with unlabeled data. So we were categorizing these fruits, different type of fruits, and we were designing a system of self-checkout if we have something like a cart. Okay, so and we are also going to and reinforcement learning was also one of that. The model learns by receiving rewards or penalties for the action that it takes. That means that we are not training the model with some pre-labeled data. The model is learning from the data itself by giving it rewards and penalties, right? So machine learning types, three types, we have covered those in Masterclass 1. And we know the basics of machine learning, right? So we don't know how to implement it. Today is the class where we will actually implementing these machine learning models, and we are going to code this in Python. If you know Python, very good. If you don't know Python, this is the best way to learn it, that is by doing. So if you have a problem and you want to get to a solution to that problem, if you're programming it on Python, then that's the best way to learn any programming language for that matter. Where I'm going to introduce you to the concepts of the Python, how we define functions, how we use these libraries, how we define data. And no worries, we are going to have a basic idea of Python also by today, by the end of the class today. All right, so let's move ahead. What are we going to learn today? We are going to learn the steps of machine learning. If you want to I would request the host to mute all the participants, please. It's kind of like really rude if to interrupt within a meeting. So please mute your microphones. So if the admin is listening to me, please mute.
You are not visible to us.
Yes, Amit, I would tell the host to do so. Yeah. Sorry
please.
for the inconvenience.
Yeah. All right, so we are going to learn the steps of machine learning. That means that how to do machine learning in general. Then we are going to learn about how to curate the data for machine learning. what is the difference between training and test data, and we are going to learn how to use Python programming for salary prediction. All right, thank you so much. So that's kind of like the basic program that we are going to learn today. We are going to use some data about some employees, and we are going to predict that what is the salary of the employee based on that data. Okay. All right, so let's start with steps of machine learning. What are the 5 steps? So if you want to do machine learning, any type of machine learning, then there are 5 steps, 5 basic steps of machine learning and how to implement that. The first step to machine learning is to get the data. That means that we need to have the data that we require to train our machine learning models. Okay, so remember in my first masterclass, I told you that machine learning is basically learning from the data. So if we have the data, if we can gather the data, whatever model that we are training on, so we need to get the data first. So data whenever we are taking data, we need to clean, prepare, and manipulate data to be trained on our machine learning models. Why? Because the data can be defective. There might be missing columns, there might be missing rows, there might be missing data. We need to normalize that data. We need to clean, prepare, and manipulate it to be used in our sessions. Third thing is we need to train the model. So whatever data that we have collected, we will train our machine learning model. So machine learning can be done by 2 ways. One is by classical learning methods, and second is by doing deep learning. So whatever method that we are training our model on, we will use the data that we have collected in the first step to train our model. And the fourth step is to test the data. That means that we will keep some of the data to test our machine learning model. And we will check the accuracy whether our machine learning model is working fine or not. And the fifth step is we will improve our model. So if machine learning model is not working correctly, then we will either change our algorithm or add some more data. Then we will get the right predictions every time. So these are the 5 general steps of machine learning. So whenever you want to solve any problem using machine learning, these are the general 5 steps that we will take all the time. All right, so we are talking about data, and we talked about data in our first masterclass itself. And there are 3 types of data: the structured, unstructured, and semi-structured data, right? So how to get data for a machine learning? So suppose I have any problem that I want to solve. Maybe my company wants me to design a model that can predict the outcome of a certain task, or accuracy of a certain method. So what I will do is I will gather the data first. And how to get the data for machine learning? So we are going to, in our class, implement the salary prediction data. So suppose if you are HR of a company and if you want to design a system to help to automate your task of predicting the salary of an employee based on how much years of experience that he has in the company, then you can train a machine learning model on that. But the first step to do that is to define the problem that you want to solve using machine learning. All right. So if you don't have any idea why you are doing machine learning or why you are designing any program for, so if you have no idea of the problem, then it will be very, very difficult to gather the right type of data. So defining the problem is really, really important. Also, when you will be designing your own solutions by the end of this internship to certain problems, the first step is to define the problem very, very correctly, right? So I believe that defining a problem is half battle won. So once you define a problem that you want to solve, but in a very intuitive way, that means you understand every detail about what you are about to solve, then you have the solution already. 50% of the solution you already have. You just need to implement the solution later on. So the second step of getting data for machine learning is defining the data requirements. Whether we require a structured data, unstructured data, what are the variables that I want to use, what are the constraints, what are the variables which are independent, what are the dependent variables. So we need to define all these requirements in this step. And then we will collect the data. So collecting the data will require various methods like web scraping, where we are we were talking about large language models when we were creating this corpus, right? So web scraping is used to crawl the whole web and extract all the data from that. So if you want to design a large language model, you will use web scraping for that. Otherwise, you can use other methods like APIs. You can use pre-trained databases. You can use surveys. You can use sensors, like weather predicting mechanism uses sensors like temperature sensor, weather sensor, and all. You can use this to collect the data. Even you can use manual data entry. So if you have people whom you have employed to manually put the data into this tabular form, then you can use these people to manually put the data also. All right, so data has to be divided into two types. Remember, I was telling about the 5 steps of machine learning, and yeah, so we were here. So remember, I was telling about the 5 steps of machine learning. So in this third and the fourth step, we need to train the model on the data, and we need to test the data. Just test the model. Okay. So what we do is basically whatever data we have, we divide that data into training data and test data. So with training data, what we do is we use that to train our model. So suppose we want to predict the salary of the employees. So we will take some part of that data, and that data we will use to train the model. That means that by any algorithm or on deep learning, whatever that is. So data that you train the model on is called training data, and usually 90% of the data is allocated to training set. Okay, and we call that the training data set. And based on that training data, the model extracts some patterns, some features, and makes predictions. Okay. Then the next type of data that we hold out is called the test data. So test data is actually the data that we will use to test our model. So remember that we were doing this training of large language models on pre-training of this large language model on a lot of text, right? And we were asking the large language model to predict the next token, and we already know that token, right? So whatever the large language model was predicting, we calculate the loss or what is the error in the output, and we back propagate that error, right? So that is the similar concept that is used in test data. That means we already know the output of the test data, and we compare the model's prediction on the base of training data on the test data, and we compare the accuracy and the error in this we try to reduce. Okay. All right, so I already told in the first masterclass that there are 2 types of machine learning. One is a classical machine learning, and the other one is deep learning method. Right? So classical machine learning involves using algorithms, machine learning algorithms, and the second one is deep learning, which involves using neural networks. Okay, so we are going to implement a classical machine learning method in today's masterclass. Deep learning is a little bit of a higher concept. We will not be able to implement it in a 3-hour masterclass, so you will have to go to other resources to learn that. But nonetheless, we are going to cover a classical machine learning algorithm and a basic of some of the Python libraries and Python programming concepts. All right, so what is classical machine learning? So classical machine learning algorithms are a set of methods used by computers to learn from data and make decisions or predictions. Okay, so we are learning from data. So these are computer algorithms, machine learning algorithms, which are kind of like methods that computers use to learn from data to make decisions and predictions. Unlike humans who learn from experience or instructions, computer need specific algorithms, right? So humans, they learn from different experiences. If we know how to identify a cat from a dog because of the experience that we have with all these animals, but computer needs algorithms to process the pictures and analyze the data, right? And classical machine learning utilizes various algorithms to analyze trends in data. So these are kind of like mathematical models of the real world, and we implement these different kind of. Some of them are mathematical or statistical way of representing a problem. Some of them use logic like decision trees. We can also use dynamic programming and a lot of different concepts. So classical machine learning utilizes algorithms to analyze trends in data, opposed to deep learning. Deep learning uses neural networks, right? So that's the difference between these two. There are two common classical machine learning methods. One is the regression, and the other one is classification. So we can use machine learning to either predict a certain value or to either classify whether to classify data into segments. So remember, we were using classification for predicting whether an image is cat or a dog, right? So we are using these algorithms to train our machine learning models onto the data that we have, and using that data we can either do regression, which is predicting certain value. That means what will be the temperature tomorrow. So if we predict the temperature of tomorrow, that is 84 degrees Celsius, some value, then we will call that regression. And if we are classifying whether it will be hot or cold tomorrow based on the temperature, then it will be the classification. It will be called classification. Okay. And regression happens in multiple ways. So there is simple linear regression where there is only one independent variable and a dependent variable. Multiple linear regression has many type of independent variables. Polynomial regression is where the relation between the data is not linear. That means the data is aligned in a non-linear form. A decision tree regression is a kind of in simple language, if I call that, it's a if-else statement. If this, then if yes, then this. If no, then this. And random forest is when we use a lot of decision trees together. And support vector regression is where we have that margin, we have that epsilon margin similar to the linear regression. Okay, so there are different types of regression methods, and each one of them has its different algorithm to predict the output based on the training data. So the technique that we are going to learn today is simple linear regression. All right, so to understand what machine learning is, basically is to extract the pattern from the data and minimize the error in the prediction. So based on the data that we have, if we can implement an algorithm that can best fit that data, then we can predict the future outcomes, right? And the key here is to minimize the error between our future outcomes and our current outcomes. Okay, so simple linear regression uses this technique of fitting the data, fitting a line through all these data points. So suppose we have some data points like this, and so these data points are basically in a linear fashion. That means there is a linear kind of like relationship between these data points. So similarly, in a simple linear regression, we want to design an algorithm that fits through the middle of all of that data. That means that there is the best fit for that data. So the prediction would be the projection of the x-axis on this line. So if we want to predict what is the value of y at 15, we will be predicting the value of the projection of x on this 15. Okay, so whatever be the value of y here, that will be our prediction. So whether it is whether it is close to the original data or not, that we will do with the test data that we have. So if I want to just mathematically formalize this algorithm, then I will write the output y as something which is beta naught plus beta 1x plus epsilon, where epsilon is error and beta naught is the y-intercept. That means wherever it is intercepting here, and beta 1 is the gradient or the slope of this line. Okay, so basically what we are doing is through all of our data points, we are trying to find the best fit. Okay, so we'll be going to implement this simple linear regression in today's class. All right, so suppose we have to, so the first step of any machine learning algorithm is to formulate the problem that we are solving. Okay, so the problem that we are solving today is to predict the salary of employees using simple linear regression. So in companies, generally the salary increases with the number of years you have worked in a company. So the number of experience that you have, years of experience that you have in a company, the more the salary your will be, because every year there is an increment, right? So we have a data set, which is the salary data with respect to the number of years of experience in the company. And I will give you a data set link. You will have to go to that link and download it from there. So let's do the first step, which is defining the problem. Okay, so develop a machine learning model to predict the employee salaries using years of experience. So the independent variable, that means the variable that we will use to predict is years of experience, to help HR make fair competitive compensation decisions based on historical data. So we are making a system for HR to predict what is the salary of the employee, so that he or she doesn't have to use manual calculation to do that. We are using data to do that, not any formula to calculate that. So whatever people that are in the organization and how many years of experience that they have and what is their salary currently. So we will predict certain trends in that salary to predict if a person has 10 years of experience, suppose. So what will be the salary of that employee? Okay, so that HR makes these fair and competitive compensation decisions based on how the company has been increasing the salary in the past. Okay, so now we need to define the data requirements. And by defining data requirements, that means that what is the independent variable and what is the variable that we need to have to predict our data. So independent variable is the variable that is manipulated or changed to observe how it affects other variable. So basically here in our example, years of experience is the independent variable because the value of the salary depends on the years of experience of an employee, right? And the second thing that is we need to define is a dependent variable. That means the variable whose values vary on the base of these independent variables. Okay, so here the dependent variable will be salary because salary varies on independent variable. So if we are talking about the simple linear regression, that means we only have one independent variable which we need to collect, and then there is a dependent variable which changes on that independent variable. Okay. And yeah, then the next step is we need to collect the data, right? So I was talking about all these steps of machine learning, and here they were, right? So first step is to get the data, and to get the data, we need to define the problem. We have defined a problem right now that we are solving this salary prediction. And we also need to define the data requirements, whether it should be structured or unstructured. For linear regression, we need a structured data. That means that we need to know which variable is where. And then we will collect the data. So the third method will be collecting the data. And what we'll do is we'll collect the samples. So I have a data set here, which I have downloaded from Kaggle. So Kaggle is a website which has these pre-collected data samples. And this is one of the easiest one that I found because I wanted to not make this class very conceptually heavy. So this data is very simple and it's very sorted. It's of a company where on the column first, we have numbers of years of experience. So these are the number of years of experience in floating points. And in the second column, we have salary of these employees. And this is the salary of these employees. All right. So remember, we are predicting this second column. So we suppose there is an employee who has worked for 15 years. So based on this data that we have, what will be the salary of that employee? And we are not using any of the maths here. What we are going to use is we are going to use this regression machine learning technique that will predict this this salary. Okay. This is a data set of 36 employees with labels. So this is a label data. That means we are using a structured data. First column of the data is the number of years of experience, and the second column is the salary of the employees. Okay, so we have already defined that. Okay, so I've got the electricity in my house. So let me quickly switch on my PC's power sources and switch on to my Wi-Fi. So let me just give me 2 minutes. I'm just setting up my system. All right, so we are back here. So what we are going to predict is we're going to predict the salary on the numbers of years of experience. Okay. First step is to get your data, and I have this link with me, which I have used this data with. So this link is going to point to this salary data set, which I have here. So I can't open that because I have not downloaded it. So what we are going to do is I'm going to paste this link on the chat box. You need to go to this link and download this data set from there. So I'm also going to do it with you. So I'm going to show the steps how you can go there. So what we're going to do is I'm going to share my desktop for now, and we will go to okay here where we will go to this link. I'll just copy and paste this link there. Okay, just need to go here and copy this link and paste it in the chat box to everyone. Okay, so I have shared the link on the chat box. So you click on this link from the chat box and go to this link. So you will be directed to Kaggle. So if you don't have an account on Kaggle, what you will see is something like this. So we will quickly create our account on Kaggle also. So use different kind of uh, and different kind of account to create to see what you will see at your PCs. So you will go to Kaggle and you'll see something like this. And to download this, you click on this download button and click on this download button here. Yeah. So it's not letting me download right now because I need to sign in. So just click on this sign in option here and sign in with Google. And yeah, so just click on and continue, and you will be signed in as this. And you can type your name here and then click next. And yeah, so the link has also been shared by my team in the chat box, so you can always check the link there. And I will just click on I agree, and my account will be created, and then I can download this from here. Okay. So, so it's not working for my this account. I'll just switch to a different account to enable that download. So basically it will look like this, and you just click on this download option. Okay, it's not working because I believe okay, so I think because I'm sharing the screen and it's a MacBook, so it is not allowing me to do this download operation. But thanks for Nagarjun. He has sent this file to in the chat box, and I'll just download it from there. Thank you so much for providing me that file. And yeah. So I have now in my downloads folder. So this is it. Okay, salary.csv. So you will also have this downloaded in your downloads folder. So this is what you will see. So years of experience and salary. Okay, thank you so much, Nagarjun and Karan, for sending me this in the chat box, because this MacBook security feature doesn't let you do certain things when you are live. All right, so whatever, we are not going to crib about this. We're going to again go to our session and resume from current slide. All right, so I want a quick rain check from you. If you have downloaded your data from Kaggle, then please type in the chat box yes. And if you are facing any problem, then quickly address your problem so that I can solve your doubts there. All right, so thank you so much. A lot of people have already started replying yes. Thank you so much. So quickly, a quick rain check if you have downloaded the data and it worked fine for you. For me, it was not working because of the security feature of MacBook that it enables certain things only when you are sharing your screen on Zoom. Okay, Anag is saying downloaded and opened. Can you please share the file over here? Thank you so much for the people who shared the file to me. So I'll be doing the same thing for people who are facing the problem. Okay. So I guess this was the file, and I have sent it to I guess Karan again. No, I don't need to send it to I need to send it to everyone. Wait. And okay, it's not allowing me to send the files also. So Rashika, if you could send the file to people who are not able to download. But I believe that a lot of people have already downloaded it from the Kaggle. All right, so let's move ahead.
Okay, okay.
Yeah, thank you so much, Rashika. So yeah, lots of restrictions when you're using it from MacBook. That's why I don't usually do it. But because of the battery problem that I had today, I had to use this one for work purposes. Okay, so let me do quick. Let's go to now. If you have downloaded the file, the second step is to write our program. Okay, so we are going to use Google Collaboratory to write our program. We could have done it in the Kaggle itself, but we are not using Kaggle to write our program because I will be providing you a template that I have already designed for you to follow while using this program. Okay, so we are going to use this template to write our program, and so we will be using Google Collaboratory. And what is Google Collaboratory? So Google Collaboratory is a IDE, that is integrated development environment from Google. So just go to Google and type Colab, COLAB, and click on the first link that you see here, Google Colab. Okay. And you go to Google Colab and you sign in using your Google account. So I'll show you how it looks like because it will always already sign me in to my account. So I'll just copy this. No, not this. This will be, doesn't need to be ChatGPT 1. So I'll just quickly show you how it looks like for you guys. It will look like this. So when you go to Google Colab, it will ask you to sign into Google Collaboratory, or it might just take you to your Colab account. Okay, so it will just take you to a Colab account because you already have a Google account, so you don't need to sign in. It's one of the advantages of having Google. And you can just create a new notebook by clicking on this new notebook option. Okay, so we are not going to do this new notebook thing because we are going to follow a template. But let me just quickly show you how a new notebook looks like. So click on this new notebook and it will take some time to load. And yeah, so your new notebook looks like this. And it has these fields that you can write your code in. So you can add two fields. One is the code field, code cell. It's called cell, and a text cell. So if you want to write anything about the code, then you will use this text cell. And if you want to code, then you use this code. So it's a neat way of maintaining your code and your nodes together simultaneously. Okay, so that's why I love Collab and the functionality. It also gives you amazing calculating power by connecting it to Google's cloud resources. So you will be using Google's cloud services to run your program. So it's a very powerful one because it uses TPUs in their cloud servers. Okay, so what we are going to do is we are going to get this template. I'm going to copy this template and paste it for you to download it to get this from Google. Okay, so I'm going to copy this and pasting this in the group chat so that everyone has the same template. Okay, was I able to send that? One more time, I'm sending it. Okay, so this link you have to go. So you have to click this link and you will be redirected to something like this. So this is the template that we will use to code our machine learning model today. And we are going to use Python. So we are going to use simple linear regression. So this is kind of like, this template is actually kind of like a way to do simple linear regression by following certain steps. So this is like a step-by-step method of learning how to do a simple linear regression using Python. Okay. So first we are going to import the libraries because we will use certain libraries from Python. People already have made these libraries to enable machine learning. Then we are going to import the data set that we require for this linear regression. That is, we have already downloaded that. And we will split this data into training set and test set. And we will train the simple linear regression model on the training set. And we predict the test set results. And we will visualize this in a plot. And finally, we'll predict the salary of an employee with the numbers of years of experience. So what you need to do is you need to click on the link that you are receiving on the chat box. Quickly do that. Go to this link. What you need to do is you need to copy this, save a copy in hard drive so that you are not working on my template. Okay, so what you need to do is you need to save a copy in drive. So click on this, save a copy in drive, and it will create a copy, and the copy will be created like this. So there will be a name like copy of simple linear regression. So what you need to do is you need to delete this copy off and add your name. So suppose my name is Amit, so I'm adding Amit simple linear regression dot template dot ipynb. Okay, so it will be a ipynb. That means that's a Jupyter notebook file. You can also use Jupyter notebooks if you have Jupyter notebooks. Okay, so Amit underscore simple linear regression template ipynb. Okay, so I'm repeating the steps. You need to click on the link that you are getting in the chat box. You need to you need to go to that link and go to file, click on save a copy in drive, go to that copy and change the copy of the name and rename it to your name, whatever is your name. So Amit underscore simple linear regression underscore template dot ipynb. All right, so I will be reserving a GPU for me from Google Colab. So I will click on this connect option and it will connect me to the cloud servers of Google. Okay, so what you need to do is you need to click on the link, go to simple linear regression, go to file, save a copy in drive, change the first name and then click on connect. Now it is connected to a runtime environment. Okay, and it will look like this. And it has 12 GB. So this is kind of like the system RAM that I'm getting. This is working on my system. And yeah, so these are resources that you need to, that you will get from Google servers. Okay. All right, so now what we will do is we will step-by-step code our simple linear regression program. Okay, quick rain check before I start coding or writing my single coding, uh, uh, kind of like single word in code. A quick rain check in the chat box if you have reached here. If you have copied the template and reached here where you have changed the name of the template and connected it to a runtime environment. Okay, so please type in yes if you have done that. Rashika, if you were able to share the file, then please share it on the chat box because a lot of people are asking me to share the.
Yes, sharing it continuously.
So Jeet is
Uh,
asking me, can you please repeat that?
even
Yeah.
Amit, even we have shared on the WhatsApp as well.
Okay, so you can also
Yeah.
get it from WhatsApp, the same file. And Jeet is asking me, can you please repeat the step to allocate RAM disk? You just need to click on connect here. So there will be a connect option. You need to connect it there. So you can just see your uh, compute engine backend here. Okay, so you can change the runtime type to another things like if you want to use Python 3, if you want to use a T4 GPU, then you can also use that. But no need to do that because a CPU would be enough to do this. So we need this T4 GPUs and TPUs for our deep learning, where we will be implementing these transformer models. What we just need is right now, we just need CPU resources. And I was talking about A100 GPUs, right? Where in which these ChatGPT has trained, OpenAI has trained its ChatGPT. So Google also offers A100 GPUs for their computing, but we are not going to use that because we will not be able to use that because we need a kind of subscription for that. Okay, so but still, like tensor processing units is available, and some GPUs are also available for high intensity tasks. Right now, we are just going to use CPUs. You just need to do nothing here. You just click on connect and you should see a green check mark so that you have the virtual environment, Google virtual environment to process your code. All right. So if you have done that, please say done. Gia is saying that there is only link in the group. So Rashika, if I am kind of like if we kind of like miscommunicated, I need you to share the file, not the link. Link is already being shared to children, so they are not able to download it from there. So you need to share the file, download it from there, and share it in the group.
Okay. Yeah.
Yeah. Okay, so no need to panic if you don't have the file. You can just repeat these steps because we will need file in our third step. Okay, when we were importing the data. Okay, thank you so much for all of you who have said or said done to reply done in the chat box. That means that we are uh, about to start our first Python program. Okay, let's start with the first thing, that is importing the libraries. That means we are going to import certain libraries. Now you can do this in two ways. In my last masterclass, I told you that nobody codes these days. Everyone uses ChatGPT, and then they can refine the code from ChatGPT, and then they can use any IDE for that matter. But that's kind of like implementing what we are doing right now. What we are doing is we are going to write the code ourselves. So we're not going to use ChatGPT to write our code. ChatGPT will of course write this code, and it will also if by using proper prompt you can do that. But we are going to learn the nitty-gritties and what is there inside the code, and we are going to learn a basic of Python language also in today's masterclass. That's why I'm not going to use ChatGPT to write my code. I'm going to type the code line by line and explain what that code is to you. Okay. All right, so what we need to do is we need to go to this line that separates these two nodes, and here we will click on this code to add a code set. We can also do by clicking on here and click on add code. So we'll click on this plus code, or the second method is to click on this plus code. So what you will do is when you click on this plus code, it will create a coding cell. Okay, so these are text cells. We are going to create a coding cell. So next to importing the libraries, we will create our first coding cell by clicking on this plus code. Okay. Now we will import certain libraries. And what are these libraries? So libraries are a collection of functions and methods which researchers and software engineers and developers have already pre-made so that we don't have to reinvent the wheel again and again. So we will be using certain libraries where all these algorithms and these functions are already there. We will use these functions from these libraries to attain our machine learning. Okay, so let's import the libraries first. The first library that I'm going to import is import numpy. Okay, numpy, numpy as np. Okay, so to import the libraries, we use import. We use this import method. So we'll use type import, and we are importing this numpy library. So we'll write the name of numpy as np. Why we are doing this as np is we don't want to type numpy every time we use numpy. So we are adding a shortcut to numpy. Okay, so first library, let's import, right? Type import numpy as np. So we are going to use this numpy library. And NumPy library is very good for processing with arrays and data. So we will be using data in this. We have a data set, right? So we need to process that data. So to process that data, we will be using this NumPy library, which is which has all these functions to process arrays and data. The second library that we will be importing is we will be importing pandas, and we will be importing it as PD. Pandas is is a very good library for data analysis. So we will be using pandas to read our data in this program. The third library that we are going to import is we're going to import matplotlib, and we are going to import the pyplot method from there as plt. Okay, so three libraries we will require in this. One is numpy to work with arrays, pandas to work with dataset, matplotlib to plot that data into charts and graphs. Okay, so three libraries we will use: numpy, pandas, and matplotlib. So quickly do this, type this code in your Google Colab of importing the libraries, and let me know when you have done. So just type done when you have written the code on this code. So you have imported all the three libraries. So numpy as np, pandas as pd, and matplotlib.pyplot as plt. Okay. If you have any issues, if you have any questions, you can also ask in the chat box till I give time for everyone to reach here. So I'll give you 1 minute, everyone, to reach here. We will start the second step, which is we will import the dataset. Okay. So there is a question from Zia that she's asking why pyplot. So pyplot is basically a library from matplotlib library. So basically a method that is used to plot similar graphs as MATLAB. So MATLAB is for mathematical works. So you can use all the charts and graphs from MATLAB in this pipeline. So let's import the dataset. If you have done importing the libraries, so Vivek is asking why use NumPy. NumPy is used for processing arrays because we will be using this data in form of arrays and matrices, and NumPy is the library that can process arrays and matrices. Yeah, matplotlib is used for graphical representation of data, and pyplot is what it is very useful for charting graphs and plots. Just similar to what you can achieve with the help of MATLAB. Okay, so the next thing is we are going to import the data set. And to import the data set, first step that we need to do is we need to upload the data set file. So in this virtual environment, we need to upload the file first, and the data the data will be extracted from that file only, right? So we will click on this folder option here, and we'll go to this upload to session storage. So basically what we are going to do is we're going to upload our file to this Google session, okay, session environment. So we'll go to downloads and click on this file that we downloaded, this salary.csv, wherever you have downloaded it, and you open that file. Okay, so and you just click OK. So now you have this salary.csv in your runtime environment. Remember that this is running on servers. So whatever it will use is from the servers only. It will not use the local files that we have stored in our computer, right? So we need to upload this file to the Google servers, and it will use this from the Google servers itself. So we need to upload this file in the session here. And after this session will be ended, this file will be deleted. So it will only remain till the session is live. Okay. So the steps to do this is to go to this folder here. I think I should just use the theme light because it is better to see in a light theme. It was adjusted because my room was not well lit. So go to this folder here, and here go to this upload option and upload the file that you have as salary.csv. Okay, so quickly do a quick rain check so that I know that you are working with me and that I can move to the next step. So if you have uploaded the salary.csv file here, simply type yes in the chat box. If you have any questions, you can ask me in the chat box also, but if you don't have, then type yes and let me know. Thank you so much, Tarun, Love, Ashmita, for replying. Thank you, Akansha, Snigdha, Mohit, Aryan. Thank you so much. I might not be able to thank all of you because I might not be able to say all of your names, but those who are giving me a rain check, that will help me navigate in this masterclass so that nobody is left behind. Okay. So everybody has uploaded this salary.csv dataset on our runtime environment. Now what we are going to do is we are going to import the dataset. That means that we need to import the CSV file into our program. Okay. So what we will do is we will use. So let's call that data database. Okay, that we are going to use. So it's a variable that I will store whatever value is in this file. Okay, so I need to convert this file into a CSV file into a dictionary format so that I can use that file in my Python program. So Python doesn't understand .csv files, right? So it needs to be converted into a dictionary file. And I will use this pandas library, and I will use read CSV, this method from here, and I will point to the file that I have, salary.csv. Okay. So what I did was I created a variable database in which I will store all of the values that are there in salary.csv in a dictionary format. And this read CSV method will convert this salary.csv, this pandas library and read CSV method will convert that file into a dictionary, and it will store that in a database. Okay. Let's see how it looks like. Print. Okay. And I execute this. Let me just execute this one. Okay, so executing this first cell, I forgot to tell you how to execute this. So you click on this run option here, run cell option. So it will only execute your first cell. So a benefit of working in a notebook environment like a Google Colab is you don't need to run the whole code, or you can make sections of your code, And if there is an error in a section, it will immediately tell. So there was no error in this code, so it ran smoothly, and a green tick was here. Okay, so I will import this data set, and I will see what is the database. Okay, so now I have this in kind of a dictionary format where this first row is years of experience and second is salary. Okay, let me just quickly clear the output. You don't need to print it. I just printed it to show how it looks like. So I have read this file salary.csv into, and I have saved that into a variable called results. Okay. Now I need to set both of the variables. Remember, we were talking about the independent and the dependent variable. The independent variable in which we will use to predict our dependent variable. Okay, so we need to specify both of them. So let me say X is my independent variable, and I will look at my file here. First, let me go to the file. Where is it? Okay, so in my file, the first column is the numbers of years of experience. Okay, so this is my dependent variable column, right? Because on the this is kind of like consider it as the input to my machine learning algorithm, right? So this independent variable, the input that I want, is in the first column. So I need to specify which is my independent variable. Okay, so I'll go to Colab. So X is my independent variable because throughout my life, I have always been kept X as independent variable, and that's kind of like general notion of denoting the independent variables. Okay, we always have to find the value of Y based on some value of X. Okay, so using that kind of analogy, so what we use is we have this X in database, right? So we'll call database, and you use this function iLock. So this will tell the location of the first of the independent variable. Where is that independent variable? Okay, so dot iLock, and in Python, the iLock takes two arguments. One is the rows. So I need all the rows. So I will keep this empty. Okay, so this first one specifies from which row to which row I need to go. Okay, so I will keep this empty because I need all rows. So from first row to last row. Okay, and I need to specify the column. Now, from first column to last column, I need to say. Okay, so why I am using, I could also have used the first column itself, right? Like the first column. And yeah, I'll show you where is the file. The file is, okay, let's go to, okay, so this is the file. So my independent variable is in the first column, and all of the rows I want it, right? So I want all of the rows of this, all the 36 rows that I have. So I will not specify any rows here, any starting or the end row. I just specify nil so that it takes all the rows. Okay. Now I need to specify which column my my X variable is. So the first value here will determine the column from where I want to start, and this determines the column that in which I want to end. Okay, I will add a -1 here because of the reverse notation of Python notebook. Sorry, the Python values, because so what we do is here, show you the file. Okay, so -1 will denote the last column. And why I'm using this -1 to denote the last column is generally what will happen is in other regressions, there might be many independent variables. So 1, 2, 3, 4, 5, 6, 7. So there are 7 independent variables, and your dependent variable is in the last column. So you want to say all the variables, all the independent variables except the last variable. Okay, so that's why I am starting the column indexing from 0 to the last column. Okay, so if you have any problem in this, then let me know in the chat. I'll be able to solve that question in the end. And we will be taking values, so I'll be calling this dot values. Okay, and then we are going to take the Y values, and Y will be in database dot iLock, and it's in the, so all the rows and only the last column. Okay, so -1 dot values. Okay, so what we did is we just selected the last column, that is the -1 column, and all the rows of this. Okay, and I have a typo here, database. And let's run this. And this is there is no error in this. I will also quickly print my X and print Y. Okay, and run this. So my X is this and my Y is this. So it has stored this in an array form, and this is my Y. Okay. So Prashant is asking, we can also give a column name in the iLoc as well, right? So you need to give the indexing. Okay, so just give the indexing. If you don't take -1, still it will go to the last. If you don't take -1, then it will select all the columns. So all of my columns are not the input, right? So only my first column is the input. So this is only input, right? So I need to go from first to the last column. So excluding this because of the so in Python the indexing is done from 0 to n-1. So suppose if you want to select from 0 to 5, then you will have to say 0 to you will have to go from 0 to 6. So the indexing is 0, 1, 2, 3, 4, 5. So it doesn't take the last one. That's why we are excluding the last column. So that last column is for dependent variable, and that's what we are selecting in the in Y, right? Just the -1. So if I just say here the 0th column, so this we could have also achieved with this. Yeah. So if we could have just said key in the first column I have my X variable, so I could have given the indexing of 0, and it will take 0 the X variables also. But why we are doing this is we want it to be generalized template. Okay, so whether if we have many independent variables, then we will be reading all of those independent variables till the last column. That's why we are using this -1 for a generalized statement. Okay. Okay, so in Y we did not have to do that. So Zia is asking in Y we didn't include a second time. So we did not include this because that doesn't make any sense. Like from last column to last column, what is this? Like doesn't make any sense. So that's why we did not include that. Okay. All right. So quickly let me know if you have your independent variable and dependent variable set. So say in the chat box, just reply with a yes, and just reply with a yes if you have coded this, and click on this run option to run this. Okay. Thank you so much those who are asking questions, because if you are asking questions, that means that you are learning more. And if you have any confusion, I will be able to solve that problem. If you are understanding that these concepts fine, then that's also amazing. Thank you so much for giving the replies as yes. That will help me move forward in my lecture. Okay. So now we have done two things. We have imported the libraries, the basic libraries that we needed, and we have imported the data set, right? Now we have our independent variable and dependent variable both set. So now we know where X is. Now we also know where Y is. Okay. So the third thing that we do is, I remember machine learning, we were talking about machine learning, right? And there were 5 phases of machine learning. And what we were doing was, quickly go there. Okay, 5 steps. So we got the data now. So we are at the first step. We got the data. This I have skipped because that's kind of like data pre-processing, and that will take a longer time. But generally, what we do is if we have like missing columns or missing rows, then we kind of like normalize the data and then fill those columns with general data, so that our machine learning algorithm doesn't predict something extraordinary if it doesn't see any data there. We use some pre-processing tools to do that, but if we have extracted that data set from Kaggle, that means that we already have a clean data. So we did not have any missing columns in our data. So we have this data and there are no missing values. Suppose if there was a missing value, kind of like this 4 was not there. So what will it expect on 0? It will be an infinity compared to this, right? So that will give an error in our prediction. So what we do generally is we do a kind of like pre-processing of the data. That means we normalize the data. We take up either mean or median or any. If I talk in simple terms, then if we mean this and put a value of kind of like 3.5, which is the mean there, so we will use that to normalize our data. Okay, so there are pre-processing tools, and I cannot cover in today's lecture, but I just wanted to highlight that importance of a clean data. If you have a clean data with you, then uh, machine learning algorithms work really well with that. Okay. Now we are going to do the third step, which is training the model. Okay. Now we need. I told you that we need to split the data into two types of data, right? One is for training and one is for testing. So what we will do now is we will split our data to training data and test data. Okay. So let's do that. I'll go to my Google Colab again. And the third thing that we are going to do is splitting the data set into training set and test set. So quickly go and click on this code option here, and we will be coding right now. Okay. So now what we need to do is we need to split the data into training set and test set. So generally what we do, if we have a larger data set, then we do a 90-10 split. That means we hold 90% of data for training and 10% of data for testing. But what happens when we have a smaller data like this, only 36 inputs that we have, right? So what we will do is we will do a 80-20 split so that we have enough test data to test our output, right? If I take only 10%, that means out of 36, there are only 4 values, right? If I do 80-20 split, that means 20% of the data is my test data, then I will be keeping 8 values for my test. Okay, so we will be splitting this data into training set and test set. So let's do that. For that, we are going to import one more library and one more method, and this powerful library called scikit-learn. Okay, so I will show you this library also. So scikit-learn, and this scikit-learn library is for particularly for machine learning. And you can go to this scikit-learn library and you can also see if you want to do classification, if you want to do regression, if you want to do clustering, there are already methods defined. If you want to do dimensionality reduction, like we were doing for stable diffusion, and the model selection, if you want to do pre-processing, that I was telling you about the feature extraction, normalization, if you want to do that, then you can also use scikit-learn. So what we need to do is right now we need to split the data set into training set and test set. So what we are going to use is we are going to use from scikit-learn. sklearn is the library, and we are going to import this model selection library, and from this we are going to import train test split. Okay, so there is already a method called train test split, which we are going to import from scikit-learn's model selection library. And for that, we need to write from, we are importing from scikit-learn.model selection and import train test split method. So this method will split our data randomly into training set and test set. Okay, so quickly write this code from scikit-learn.model selection. So that means from this library, from model selection, we are selecting this train test split method. Okay. So this train test split method. And we are going to define our training data and test data. So now let's define that. So training data is xtrain, and test data we will define as xtest. Y like the output will be ytrain and ytest, and I will use this train test split method to fit this this data. Okay, so we are splitting basically into training set and test set. So we have independent variable as a training set and independent variables test set, and the outputs training set and test set. Okay, let's call them input output. So input training set and input test set, output training set and output test. Okay, so we'll use this train test split method, and we are doing it on X and Y, this one and this one, and test size should be 20%. So I'm giving 0.2 here, and let's add a randomness so that your output and my output is same. Let's say random state is 1. Okay, so you will need to keep this random state at 1 so that it's only for educational purposes. That means that you and I will have same output. Okay, so what we need to do is we need to, I just cut this and I'll zoom it a little bit so that you also see it. So from scikit-learn.model selection, we are going to import this train test split method, and we are going to split our data x train. So we are going to define variables x train, x test, y train, y test, and we are going to use this method to split x and y with a test size of 0.2. That means 20% for test data, and random state is 1. Why random state is 1? Because what train test split does is it randomly splits this data into training and test set. So if we keep this random state as 1, then your and my mine data set will be same. Okay, so just for educational purposes, so that later on you will say that, sir, my prediction is something different than yours. Okay, so let's keep that random state as 1. All right, so if you have reached here, if you have coded this, then just click on this run thing, and it will split this XY into train and test data. Okay, so we have run this. So let me know in the chat box with a yes reply if you have done this. Okay, I'll also read to some questions if you have here, then. Okay. Okay, Zia is asking, sir, what if we train the model on 100% data, which we have, and test model by random data? It can happen. So if we train the model on 100% data that we have, we will not be able to determine the accuracy of our model, right? Because if we test it on a random data, then it will give a random output, or a output according to that random data, but we don't know what our output should be, right? With splitting our data into training and test data, that means for the test data, we already know what is the input and what is the output. So if our model is predicting something, we can check it on the base of our test data so that error can be minimized. So if there is more error in what the model is predicting, maybe we will not use that model, right? So that's why it is very important to split our data into training and test data. If we use 100% of data to train our model, then what parameter we will test it on, right? So we will not know whether it is predicting right or wrong, because we don't know the output of a random data, right? Thank you so much. Very interesting question by Zia. And some other questions. Okay, showing name X is not defined in my screen. Prathamesh, you have not run this cell, so you will need to run this cell. So until unless you run this cell, the IDE will not remember this. So you run this cell and run this again, your error will be removed. Okay. Are there any specific values that we should use for the random state? Many people suggest using values like 42, 0, or 99. Is there a reason for this? So there is no reason for this. The only reason to specify the randomness is for educational purposes only. That means that my randomness and your randomness is similar, so that it doesn't split this data randomly for me or for you. So if I don't keep this, then my data set and your data set will look very different. And when you will plot, then we will, so when we will plot, we will have different results. Aman is asking me, can't we have both test and train data as 100%? Okay, very interesting question. If we have test and train data both 100%, then that's a case of kind of like overfitting. So overfitting is that we are trying to fit every point in our data. Now, if I show you a very interesting question, this, if we split it for 100%, 100%. Okay, so this is here. Now, if I want to kind of like fit a line, then why can't I fit a zigzag line that covers all the plots, right? So, but what will it do is, my idea of using machine learning is to predict future results, right? Now, overfitting, that means if I'm fitting every data point here, will not give me any generalized form or any generalized way of understanding this data. Basically, I am covering all the data points. So my training data and my test data are both 100%, and I am predicting the error that my training data should predict always the right result. So it will lead to overfitting, and the future values will which we will predict will not have any kind of like uh, we will not have any sense of what our future value will be. So our whole idea of prediction will be just lost if we are just uh, just calculating our output on the base of it. So we are not learning anything from that, right? Random state take only Boolean values as 0 at 1. No, Zia, we can reinstate random state as anything. Okay. So random state is basically, so Tarun is asking, what is random state? So random state is basically, wait. Okay, so here, what this method does, train test split does, is it randomly splits this data from X and Y to training and test set. Okay, so random state is kind of like fixing a kind of like randomness, so that my randomness is of the state 1, and your randomness, if you give your random state as 1 also, then your randomness will also be 1. That means that it ran it is kind of like randomizing, but with a pattern, if I explain it simply. Okay, so your pattern and my pattern will look same. If I do it 10 and you do it 10, then your pattern and my pattern will look same. Okay. All right, so let's go to training part. Okay, so we have now split our data into training set and test set. Now we are going to train our simple linear regression model, and we'll do it on the training set, right? So let's code. If you have done this, then quickly on the chat box type yes, so that I know that you have written this code, and I can just scroll down to move to my next line of code. All right, thank you so much for giving the rain check, those who are writing yes. It is a very small thing that you are doing, but it means a lot for me. Okay? So just type yes. Okay, so let's move on to training our model. Okay, so a lot of people have said yes, and thank you so much for replying. Let's move on to training our model. Now we have split the data into test set and training set. Now we are now we are training. So to train our data, we will go to scikit-learn, and scikit-learn is very powerful. So what we are doing is we are doing regression, right? So we'll go to regression, and we are using this linear models. So we will go to linear model, and we are doing linear regression. So we will go to linear regression, and we will see what we can use to do linear regression. So why I am showing you this and why I'm not writing the whole code in here, I could have just written from scikit-learn dot linear regressor, sorry, scikit-learn dot linear model import linear regression. I could have done that, but why I want to show you this is because if you don't want to do linear regression, whether your problem is of a multiple linear regression, suppose. Okay, so it's not a simple linear regression, or it's a polynomial regression, or if it's a decision tree. So scikit-learn, you can follow scikit-learn to, suppose it's a support vector machine for regression. Okay, so what we can do is you can go to SVR and we can see how we can use any type of regression and where we can import it from. Okay, so what is the use case? What are the parameters that I need to fill inside these methods? So you can explore this scikit-learn library to your own use cases. Right now, what we are doing is we are doing simple linear regression. So we'll go to linear model and linear regression from here. And yeah, so this is the class. So the class is scikit-learn.linear-model.linear regression class. So we are going to import this class, and we are going to use this class to fit our data. Okay, so let's quickly do that. So again, as you already know, we are going to use from sklearn dot, and it says, where is it? Linear model. So dot linear underscore model, import, what we are going to import? Linear regression. So we can import this linear regression class. Okay, linear regression. Okay, note that the L is capital and R is capital, and also you can check whether you're writing it right or not by Google Colab suggesting you the right thing. Okay, so linear regression, if I type this, if I would have typed just something like this, then it will not show anything here and it will not tell me. So my code is not right, that means. So if I type something here, then it shows me the linear regression. Then yeah, so remember that it is capital, the R and the L, and we will import that. Okay, so from scikit-learn linear model, we are going to import this linear regression class. Okay, now what we will do is we will create a variable which we'll call regressor. Okay, so let's create a variable regressor. What it will do is it will use this regression class, this linear regression class, to uh, to to do the linear regression. Okay, so what it will do is it will inherit this linear regression class. Okay, so this regressor is this linear regression class. So I'm creating kind of like an object of this class. Okay, so I'm trying to not use a lot of like programming jargons in this, so that to avoid confusion, but I will use some of the jargons that are used in other programming languages so that you understand these concepts. So basically what we are doing is we are creating something which is a regressor, and we are using this linear regression class to create that regressor. Okay, now what we'll do is we will use this regressor and this fit function. So this fit function here, and on my data. Okay, so what was the data that I'm fitting this linear regression on? On what data I'm doing linear regression? I'm doing it on the training data, right? So X train and Y train. Okay, so I'm using this, I'm creating a regressor using this linear regression, which some scientist or some researcher has already coded in Python, and those amazing people have made it open source using this scikit-learn library, and I'm using this scikit-learn library to import this linear regression class to create my regressor, and I'm using this regressor to fit my X training data and Y training data. So basically what this regressor will do is this regressor will find this line. Okay, so this line which fits through my data, and with this line has the least error. That means this line has the least distance, mean square distance from all these points in my data. Okay, so I will use this regressor to fit this linear regression. Okay, and I will just run this. I can also do a shortcut of running by pressing shift and enter. Okay, so if I press shift and enter, it will run. And when it runs, it will create a linear regression object. Okay, so linear regression, this linear regression. Okay. So if you are here, then if you have typed all these 3 lines, then say yes in the comment section or the chat box. And if you are not here, then let me know if you need more time. If you have questions regarding this, please shoot in the chat box. So Akansha is asking, sir, can you explain this splitting part one more time? So I will explain it by the end of it. Okay. A random state I have already defined. Okay. So any other question? So Anag is asking, sir, when we import all the rows, how does it determine that the year experience and salary are the names of data and not part of the data? So we have already stored this data set as a CSV file, right? And in CSV file, generally the first row of the file is basically the labels of that file. So that's the benefit of storing this file as a CSV file. Okay. What else? So Vivek is asking, sir, please explain this one more time. So to explain this one more time, let me do that. So what we are doing is we have splitted the data set into training and test data by using this train test split method from scikit-learn. Now we are going to fit a line through all my data points. Okay, now I know what is X and what is Y, right? So I want to fit a line that has the least error, that is in the least distance from all these points. Okay, so that line represents kind of like all these data points. Okay, so it's a kind of like assuming that a line which passes through the least distance between all these data points. So the distance between this point and this line is least. I cannot the mean distance actually from all these points should be the least. I cannot draw any other line which has the least distance from all these data points. Okay, so that is what we are actually doing in linear regression. Okay, basically we are kind of like generalizing the pattern of the data. Okay, so what we are doing is we already have this linear regression class in scikit-learn library. Some researchers, some scientists had already made this class to do this for us, and we are going to import that class. Okay, so in scikit-learn, when we go to scikit-learn and we go to the library that we have, and this regression, if we go to this regression library, then this linear model, if we are doing linear regression, then we will go to this linear regression, and we will see that from scikit-learn.linear model library, we can import this linear regression. Okay, so this linear regression class will do the linear regression for us. So what we did was we imported that linear regression and we created an object of it. So we created a regressor which has the properties of linear regression. Okay, so now then we used a function inside linear regression. We used a fit function to fit that line on X train and Y train. Okay, so that's the explanation. All right, so if we have trained our data with linear regression, now what we will do is we will predict the test set results. This thing, okay? Let's code this predicting the test set results. So remember, we now have trained our model. So now we have our model ready, our linear regression model, and we know what will be the values of y, the predicted values of y based on this model. Okay. Now I am going to predict the test set results so that I can compare it with my original values. Okay. So let's do that, and let's call that y prediction. And what we will do is we'll use this regressor object again, and from that From there, we will use this predict function. Okay, now we are predicting y on test set results, right? So we will use the test variable, which is x test. Okay, so y prediction is regressor dot predict. So we are using this predict function on x test. Okay, so quickly do that and run this. Okay, so a little bit of summary so far before I move ahead. What we did was we imported the libraries that we needed. We imported NumPy, we imported pandas to read the CSV file, NumPy to work on arrays, matplotlib to plot our data. Okay, and then we imported a database. We called it database, and we read it using pandas library dot read CSV function, and we also uploaded this salary.csv. Okay, and then we located where our independent and dependent variables are. So x is at first column, and we denoted it by this, and y is at the last column. Okay, and then we split the data set into training and test set. So x train, x test, y train, y test, and then we trained our model on simple linear regression, and we imported this linear regression class. We made a object of this linear regression class, and we fit that the x train to determine that line that passes through the least square of distances between all the points. Okay, and then we predicted the y values on our test data. Okay, so what we are doing is basically we are predicting y on test data so that we can actually see if our prediction is right or not. Okay. All right, so now we have done all of the work. Now we will visualize the training results. Okay, so now we have predicted our values, we have trained our model on linear regression. We will see how it looks like. All right, so remember you imported this matplotlib library, right? So we will use that matplotlib library to visualize our results. Okay, so let's plot the input, whatever data we had first, TLT. So we remember that we have done this here. We said we imported matplotlib.pyplot as PLT. So we'll use this PLT here, and dot scatter. I'm going to plot a scatter plot on X train, that is my training set, Y train, and let's see how it looks like. Okay, so let's plot X train and Y train. So we are basically plotting our input and output. Okay. So basically what we are plotting is we are plotting this. So on the base of what values of X, what is Y? My original data. Okay, why I am plotting this? To show what a predicting the linear regression line will look like. Okay, so this I'm plotting a scatter graph because of the points that I have here. Okay, let's color them. So color would be blue, let's say. You can make any color. And let's plot. Okay, let's plot X train, TLT.plot X train, and the line, right? The line that we get is so this is regressor dot. So we use this regressor dot fit X X train Y train. So the line we will get from this regressor, right? So sorry, this. So we are plotting the X train, and we are plotting the values corresponding to Y in this. So we will fit regressor dot predict. We will predict on the base of X train. What we are predicting on the base of. What we can also do is, let's not do it here. Let's not do it here. Let's make a variable. Okay. So let's here. Let's also make Y regressor. So Y regression is regressor dot predict X train. Okay, so this is nothing but what I'm actually creating the plot values for the regression values of y. Okay, so regressor dot predict x train. Okay, so now I have y prediction, which is the prediction and test values, and this is the regressor model on training values. So let's type this in. Okay, y regression. I just move it a little bit up so that everyone can see that. Okay, so we have this, and let's color this as red. Okay, so now I have plotted my input and output of the data that I had previously. I have plotted the line on the base of x values, the regression line. So y regression, which is regressor.predict x train, the x train values, and that color is red. Okay. Let's call the title of this as salary versus experience. Salary versus experience. And this is for training set. Okay. So the title of my graph will be salary versus experience, and that will be in the training set. And let's also label it X label. Sorry. Here's experience. So X is my years of experience, and Y is salary. And then I will call the show function to plot my graph. Okay. So what I'm doing here is I am going to plot the scatter plot of my input and output of the original data, and then I'm going to plot the regression model, that is the line that passes through all these data points. I have coded this as blue and this is red. The title of my plot is salary versus experience of training set, and the years of experience is my X and salary is my Y. Okay, and I want to show it. Let's see what the results are. All right, so I have got this nice plot of this line that passes through, that generalizes this pattern. Okay, so it is kind of like extracting some feature or some pattern from this data, and it is defining that, okay, this data is linearly moving in this pattern. So if a person who has a 15-year of experience, that value somewhere will come here. All right, so that's a linear regression that we are doing. All right, so if you have typed this, if you have coded this and have got the graph, then quickly type done in the chat box. Thank you so much. That's a small favor that you can do to me. Okay. If someone is getting error for color function, then he must be using this, and this is not how Python understands color. COLOUR. Okay, so this is not how it is coded. So you need to code it as COLOR. So generally in English, in the English that we learn in India, we generally write COLOUR. It's an American English, so COLOR is the right. Okay, so if you are experiencing any error on color, then that's how you can reduce it. Zia is asking me to explain this step. So basically, Zia, what we are doing is we are plotting our values. Okay, so we want a graph. So I told you in my linear regression, right? So in linear regression, what we are trying to do is we are trying to fit a line. We are trying to kind of like extract a pattern in this graph, so that a pattern extract a pattern from this, that these points have some pattern. Okay, so Pratham has got error in the second line because you have not executed the first the code before. Okay, so what we are trying to do is we are trying to fit a line that can generalize all these patterns. So we are trying to visualize that. We have already done that. We are just plotting it. So we plot this using this matplotlib pyplot, and this is the function that we will use, plt. We have created a shortcut for that. So scatter plot is used for this scatter points, because this is not a continuous variable. It's kind of like a discrete variable. And now we will plot this regression line by plotting this x train and y regression. And I have defined this y regression here. Okay, so this y regression is basically whatever the output we will get of the regressor on our training set. Okay, and then we plot this. So the second line plots this red line. Okay, and the first line of this code plots this scatter plots. Okay. And you will so Suraj is asking, can we do this without using scikit-learn module, means by scratch code? Okay, so you want to do it from scratch, right? So to do it from scratch, you will need to understand the mathematical model of linear regression. So basically, linear regression is basically what we are trying to do is we are trying to find a best fit, a line that minimizes the error of these the distance of from this line. So basically, we can use this kind of. So I will show you. So basically, we are trying to predict y, and we need these beta naught and beta 1 values. Okay, so if we get this beta naught and beta 1 values, then we kind of like will have this line, right? So what we can do is we can use any of the we can use this error function. So so this error function we will use. So error is the mean, actually the average mean square error. That means y not y predict minus the y actual and the square of that, the distance from that. Okay, so root mean square values. And by using any of the algorithms like which can optimize this error, maybe like gradient descent. So we will use this gradient descent to train the function on to minimize that error. And when that error will be minimized, we will be getting this beta naught and beta 1 values. Okay, and by using these beta 1 and beta naught values, we will be able to find this right. So we'll need to go into mathematical understanding of this if we don't want to use the scikit-learn library. So the person who has created this code in scikit-learn library, he has that mathematical understanding of course you can do that, but you will need to go into deep on how to what is the loss function and what is the optimizing method that you are using, and how can you code. Okay. All right, so let's move ahead. Okay, so now x level and y level are built in already. Yes, x level and y level are built in functions, and if you provide any values to this, then they will reflect. Okay, so x level is years of experience and y level is set. All right, so we are here. Now we are visualizing the test set results. Okay, to save some time, I will just copy the same thing. We will change some values. You can also do the same. So you copy the training set results. We are doing the similar thing with this. So you paste it here. We will save some time in this. Okay. Now what we need to do to change here is basically first here the scatter plot of x test and y test. Okay, so because we are doing this, and we are plotting the same line. Okay, so this will remain same because the line is same. We just wanted to visualize how the line fits our test results. Okay, everything will be same except this. Okay, understood? This plot we don't need to change it to y predict. Why we are not doing that? Because we want to see if the plotting the scatter plot of the test set and how the line that we predicted fits the test set. If the line fits the test set perfectly, then that means that our model is working, right? So let's execute this, and I believe that this fits these data points really nicely because there is very small difference between, except for this one is the outlier, except for this one, it predicts most of the test results very, very correctly because it is very near to the data points that I have. Okay. Mariam is asking if she could get the attendance because she has her she has her laptop going to be shut down. Mariam, what we will do is we will send you the WhatsApp the attendance link on WhatsApp, so you can do that. Okay. So basically, our test set is basically our linear regression model works fine here because now the line also predicts correctly the test set results. Okay, so basically, we have now got a model, basically a line. If we can approximate the values on this line, then we will be nearly right in our predictions. Okay, that can be seen by this. So basically, on 2, the value should have been somewhere here. That means around 40,000, 43,000, 43,000. But it is predicting somewhere around 42,990, which is very close to the value, right? So the prediction is very, very close. The error is very less. So I can see that this line fits my curve, fits my points perfectly. So my model is working right. That's the importance of test set also. Okay. All right. So let's move on to get this working. So let's predict the salary of an employee with numbers of years of experience. So let's create a user interface. Okay. Let's create a user interface. Let's make a variable of years. Okay. Well, before I move, I'm really sorry. Before I move, I need to quickly do a rain check before we move to the last step. Who have got the train set results and test set results? Please quickly write in the chat box yes. If you have any question, then please let me know. Okay. Thank you so much. You're doing me a huge favor by telling that you have got it. Okay, so that we can move ahead in the lesson. If you have any doubt, any point, then we can take that doubt by the end of this class. We will quickly finish by creating a user interface. Okay, so okay, so let's predict the salary of an employee with how many numbers of experience that it has. So let's create a variable of called years, and let's take input. So enter the number of years of experience. So those who are new to Python and those who have no idea of how to take a value as an input. So input is the method to do that. And we are creating a variable which is years. And we are taking input by saying this, enter the number of years of experience. Okay, so basically what we are doing is we are creating a kind of like a user interface where a user can input some values and we can predict the output depending on the values. Okay? And we will use our linear regression to predict that. Okay. Now, let me not do that first, and let me put the. So what we will do is now let's call our output as prediction. So years as the input and prediction as the output. Now we'll use this regressor dot predict, and we'll use this to predict the years. Okay. So right now I'm showing you how the errors might occur. Okay. So let's execute this. So we will improve our code later on. So let's execute this one. Okay. So now it will ask me to enter the number of years of experience. Okay. So let's include a space also here so that it doesn't go back. Okay, so I hope it has not restarted everything. Yeah, it has restarted everything. Let me just run everything. Okay. Just waiting for this. All right. Now let's do that. Okay, so what happened? We took the value of 10, but it gave me an error. Okay, so and why is that error? I will just show you. So it is predicting the salary on the base of our model, but we give the input as as 10. But the input method here doesn't understand what 10 is. Okay, so let's work on first errors first. So it takes this input as string. That means it takes this as characters. Okay, so we need to change this. Uh, so change this to input. Wait, let's convert it into integer. Here's this int equals int, and we will take that inside. So basically what we are doing is we are converting the string to the integer. Okay, so we converted this input into integer, and let's run that. And here we need to put here's integer. Okay, so if I do it with 10 and then execute this, again it shows an error. Now the error is that input is scalar. That means that it is not an array. Okay, it's a scalar value. So I need to convert this to an array. Okay, so because what we are doing is we are working on arrays, right? So we are working on this X variable here, which was an array, Y variable, which was an array. All the training test results are on arrays, and this regressor only takes input as arrays. Okay. So now what we need to do is, it says that it expected a 2D array, but got scalar array. Okay. So it's not a scalar array, so it's convert it into array. So we need to just include these two brackets, the starting of the two brackets and end of the two brackets, to convert this into a two-dimensional array. This scalar is converted into a two-dimensional array. And if I do this, then my error will be removed. Okay, now let's print that. Print the salary of an employee with numbers of years of experience. Let's call that years is is prediction. All right, so let's execute that. And it says that the salary of an employee with numbers of years of experience 10 is this. So it predicts the value. Okay, let's try for 15 and predict that. And the salary of an employee with number of experience 15 is 15,93,000. Okay, let's do one thing that let's try one thing, and it should give error in this. Let's try a floating point. So the years of experience can be in floating points also, right? 15.6. Let's see. So if it takes, it will not take that value because it's not an integer. So let's convert this to float. Okay, so and we call that. Let's not change that, because let's change that. Doesn't matter. So we'll change it for, so let's say 5.6, and we'll change it here also. So years int is years float. And for 5.6, years of experience, the salary would be 77,500. Okay, so we are now getting the answers. Okay. Yeah, so I purposely gave errors because purposely included errors, so to let you know what is the meaning of this code. Okay, so we input the numbers of experience, and we whatever we take as input is always in string, so we need to convert it to float or integer for that matter. And then we use this prediction because that was a scalar, so we need to convert it into a 2D array. So when we convert it into a 2D array, then we can predict. Okay. All right, so quickly code your. Okay, so Zia is asking why it took two time, right? So two times this. So that's the question, right? So let me just show you the error. That's why I was showing you the error, what the error was. Okay, so let me just do this. And it says that it needs to be a 2D array. Okay, so two-dimensional array. That means that it needs to have two dimensions. Okay, so if I include this, that will be my one-dimensional array. Right? Let me do that with this. Okay, so it requires a two-dimensional array. That means that, yeah, it got one-dimensional array instead. So the method is made such that it takes these two-dimensional arrays. So that's why we need to include this. I will also solve your doubt by showing you our test data. Okay, so let me quickly show that. So my test data was here. So let me just add a sum. Okay, so if I print my x test, okay, so let me do that. And so here also you will see that it's a two-dimensional array. That means it's an array of arrays, right? So this is the first block, starting of the of the second dimension, and this is the first dimension of the array. Okay, so even the train test split method, it split it into a 2D array. Okay, basically the mid. So because we will use this to split it for different independent variables. So that's why we need a two-dimensional array to store all those independent variables, right? So that's why we needed the double quotes. Okay, I hope your problem is resolved. Why are we not taking years as an integer? We can take years as an integer, but in our data set, we have years as floating points, right? So 2.9, 3, 3.2. So that's why we can use float. Okay. All right. So congratulations if you have your code, and yeah, I guess this. No, not this. Okay, so my code, where is my code? Yeah. Okay, so we have made a simple linear regression model using Python, and we have predicted the value of employees. We could also plot this. Now what you can do is you can play around with scikit-learn library. You can always go to scikit-learn. If you can see different kind of patterns in your data, suppose it's not a linear fit, if it's a polynomial fit, or you want to use something else, you want to create a classifier, then you can go and use scikit-learn libraries. So yeah, so you can do it for supervised learning. You can also do unsupervised learning in this. You can do clustering, many different machine learning algorithms. Okay. All right, so let's do this. Okay, so Zia is asking, why is it different salary on the same experience you and me entered? Okay, so did you enter 5.6? What is the value that you get? Zia, if you could just let me know in the chat box. Okay, so you got 81. What is your random state? If you need to specify the same random state. Your random state is 1. Okay, same random state, and you are getting different result. That that should not happen like that. So your plot, this plot is also similar to my plot. Is this the same? Okay. So you are getting a different value, and I'm getting a different. Even this plot, right? Okay, so Mohit is saying that he is getting same as my values. Zia, if I could understand the problem a little bit more, then I will be able to, I guess, predict better, tell better. So, did you have like, yeah, so Chanakya is suggesting that you might have like different kind of test and training set, yeah, data size. So, did you use the same data size, like 0.2 as you mentioned, where when we were splitting it to training test, like test size is 0.2, right? What you can do is you can rerun it from this. So go to runtime and click on run all, and let's see if you have forgot to execute any code cell. Okay. So here you can just go to runtime and click on run all, and let's see if it is same. Because the data set was same, so I believe that all of us should have got the similar values. It should not, it cannot be different. Okay, so Anag is suggesting me, sure, shouldn't it be float? Yeah, yeah. So I converted it later to float. Yeah. So I just wanted to show that the integer example was just to show the errors so that you can literally move on to float. After running all, now it's the same. Yeah, of course it will be same because you might have forgot to kind of like execute some cell. Okay. All right, with same randomness, we can't get different values because we will always get the graph that we got here as same. So if we have got the same graph, then that means that on 5.6, which is somewhere here, we are getting this value which is here. So that will always be around 77, right? So you can see it from the graph itself. So for 5.6, you can see that it is around 77. That's uh, Anshu is saying that the different answer is because every time when the data set train itself, it takes different values. It takes different values if we don't specify the randomness, right? So if we have already specified randomness, right? So here we have specified where is it? When we were splitting it. So random state is 1. So if my and your random state is 1, that means it is kind of like fixing the same fixing it it's kind of like classifying the data in a similar randomness. So your randomness and my randomness will be same if I specify that my randomness state is 1. Okay, so if we have specified that, then it will not randomly kind of like split it. Okay, so we have been here to the end of this lecture. If you have any queries, you can always ask me. Let me quickly share the. So, yeah, not too fast. All right, so today's attendance link is here. Link is similar to the one that is for the last time. Just the attendance code is changed, and Hinton is the code, and it's a tribute to Jeffrey Hinton, who is a pioneer in data science. He's also called the godfather of AI. So that's a kind of like general knowledge that I can. So Jeffrey Hinton is a scientist, and he's called the godfather of AI. And I dedicate this lecture to Jeffrey Hinton. And that's the attendance code for you today. All right, so we are at the end of this, and we have some of you have asked like beautiful questions, because the thing that we can do is, if we don't have a right answer, it is very important to ask the right question, because asking right questions will always increase our learning. So thank you so much for being participative. Thank you all for those who were writing and coding with me and sending me a rain check each time you were replying with a yes, so that I could move forward in this lecture. And we were about to complete it in 2.5 hours, but because you were so quick and you were so focused, that we finished it 10 minutes early. So we have more time for question answers. before we move on to some important announcements, this is my LinkedIn link again. So if you are designing your machine learning models, and if you are writing some code, or if you are designing something, then please keep me posted on LinkedIn, so that I know. And if you have any error in any code, if I could help you in any way, then that would be my pleasure. So you can always contact me on LinkedIn, even if I am not on the live sessions. If you are unable to ask the question due to any difficulty that you had, so you can always contact me on LinkedIn and ask your questions there. I'll be always replying on LinkedIn. I always reply. So that's the promise that I can do. All right. So before we move on, uh, some important announcement from Rashika. So Rashika, over to you. So this is the attendance link, which is right here. And the people who have questions, they can ask me questions always. So I'll be reading the chat box till Rashika announces the announcements that you have.
Thank you, Amit, for such an excellent and engaging session on artificial intelligence. I can see many of the students were actually, involved into the sessions, and they were doing the live projects and everything. It was such an engaging session. I really personally enjoyed a lot. Dear students, please provide your feedback by filling out the attendance form. The link has been shared in the chat box by my colleague. Also, the QR code is available on the screen in front of you. You can scan the code and you can, fill in the attendance. So yeah, the announcement with regards to the deliverables, you have two learning plans that has to be submitted by 28th of July. The second deliverable is the concept note, which can be consist of 1,000 words, and third deliverable is the PPT and the chatbot making, which the chatbot, how to make your chatbot, that is all about your masterclass 5 that will be conducted. Okay, so over to you, Amit. If some of the students have any doubts, you can take it up.
All right, so I can't see any of the doubts in the chat box. No, I can see there are. So okay, so let me read some of the one. Okay, so Chanakya is asking, does the efficiency of the model alter if we change the percentage of training and test data set? Yes, it will. So basically what it is doing is it is actually taking the root mean square error of the points to the line that we are plotting, right? So basically we are predicting a line which will fit that. So if we have uh, less training data, then we have less data points. And to fit those less data points, we will be having some different slope of the line that we are trying to fit. So let me just quickly go to my slide where I was explaining that. So basically, if we keep your training set less, so if you don't include these three, suppose, okay, so it was 80% or 89% for that matter. So if you don't include these three points here in my data set, then that line might not go like this. It will have a different slope. Okay, so if this line's slope has changed, because now it will not try to fit this point, right? So it will have a different slope. So the prediction will also change. So once we have so if you have less data, like let me just show you if you can get it, if you get different results. So if we have a test size of 0.5, let's say, so we are splitting it 50-50. So training data is 50 and test data is 50. Let's see what is happening. So I'll just okay. So 5.6, it was around 77,000, right? So let's do the same, 5.6. And now it has changed to 76,860. It has not changed too much because I kind of like input 5.6, which comes around somewhere here. So I split it fifth by half. So now I have less data points in my trainings, right? See, this is my training, and now my test set also has more data points. Although the line of prediction is fairly good because all these are in linear pattern, it might not affect that much. But because I excluded some of the points, now the line that I am plotting, the slope of that line will change. Okay, so the more data that you have, the better your model will be in predicting. The less data that you have, the lesser better the lesser your model will be in predicting. So that's why data is like really important. So if I had like thousand people's data in training my algorithm, so training the algorithm is basically when we are when we are actually predicting the outcome. Test, if we are keeping some data for test, that means that we are not predicting the outcome of test, we are just testing our outcome if it is right or not. So the more training data that we have, the more accuracy or the efficiency of our model. Okay. So the best, how to find the best possible split percentage for the best accuracy. So the industry standard is 90-10, and that you should use 90% of the data. If you have a very large data, then you can do 95-5 also. That depends on how much data you have. So if you have like a data which contains like 20,000 rows, then 95-5 also will be fine, because 5% of 5% of 25,000 is also 400, right? So you will have enough data to test your okay. So that depends on the number of data that we have. So we did a 80-20 because we had less data. So if I would have done 95-5, then I would have only one value. So 5% of 30 is what? 5% of 30 is around 1.1, so 1.6. So I will have only one or two data points. So I will not be able to see whether my model is working well. So that's why I took 20%. Okay. Please describe about the project we have to design. So project that you have to design, I will describe you in the chatbot designing masterclass, where I will be giving you the problems. So you'll not be designing a machine learning model, you will be designing a chatbot, because we are going to basically learn more about IBM tools in the next masterclass. Concept note is basically what concept note is basically for a project. So what problem are you trying to solve? What is the solution? And what is the tool that you use to solve that problem? That is the concept note of a project. Okay, so Pratham, your answer is here. Okay, and all right. So if anyone has any queries, we can still have them. We have 3-4 more minutes in this session. If you are done with your queries, then you can leave the session. Please do code, like do practice this when you go from this masterclass, so that you always learn. Right. I enjoyed a lot in today's masterclass. I hope you too. Thanks a lot for being so much participative. It's a very good evening and a very good night. Thank you. Okay, so I have one more question. What type of machine learning is required to make basic antivirus software? All right, so Vivek, you want to make a basic antivirus software, and you want to use machine learning to make that. Then that depends on I can like if you can make this into a really compelling problem statement. What are you actually trying to solve? Then only you can train a machine learning model to do that. So basically, we are detecting viruses. So we are making an antivirus which is detecting viruses. So what we need to have is we need to have the pattern of these viruses, and the base of the pattern of these viruses. We need to have a data of these viruses and how it affects the file, and then basically we have to design a machine learning model if we want to do it with a machine learning. Basically, like we should not do it with a machine learning model. I hope that there are some other techniques that can make better antiviruses without using the machine. Machine learning is basically kind of like detecting patterns in the. So yeah, of course, like detecting virus is also kind of like pattern detection. You need to understand what is the underlying code behind that virus. Yeah, yes, of course. Like in the modules we have learned about adversarial attacks. Is it come under cybersecurity? No, adversarial attacks. Yeah, you can use machine learning for. So you need to understand. You need to predict the kind of like the pattern that these adversarial attacks are happening. So basically, you are not identifying the root cause of of these viruses, but you are detecting these patterns, and if you have enough data of error is what error you are getting. So basically, if your files are kind of like missing, then you need to and you know, and your data tells you that this is the virus that is causing that file. And if you have a database of all these error types, then you will be able to predict the kind of virus and then can use the kind of technique to counteract that virus. Okay. So that's a use case that I can think about of machine learning. And I have not designed any antivirus using machine learning, so I will not be the right guy to point out, but I can only point out towards the basic or the algorithmic version of how it might look like. Okay. So okay, if I want to make weather forecasting app, then should I use KNN or support vector machines? Now that needs to be decided on the base of the data set that you have, and basically machine learning modeling. They're basically using machine learning in real life is whether the machine learning model is predicting it right or not. So k-nearest neighbors or support vector machines, both of them are really powerful. KNN is better in uh, uh, kind of like creating clusters and creating a specific boundary to specify different types of data. So basically, it depends on whether your KNN is giving you a right prediction or your SVM is giving you the right prediction. And it really depends on the trends of data that you have from. So I can give you this generalized advice that machine learning, no single model fits all the data. Okay, so we are still, that's why we had to use deep learning, right? And classical machine learning methods are very good, but they need to be applied on a certain type of data. So if your data is uh, being trained on KNN and it is predicting better or classifying better or than SVMs, then you will use KNN. If your data is something which is being fit by SVMs better, then you will use SVMs. So no single model fits all because the data is very different in different places. So that would be my answer. So depending on the error in the prediction, you can choose your models. If your weather data is like linear, like it is the temperature is increasing in a linear way every day, then you can use linear regression also. Why to use KNN or SV? Really depends on the data and the prediction that you are getting. Okay, I will share the PPT of today's masterclass. Thank you so much, everyone. And this will be my final goodbye. We will be meeting in our next class. And to create okay, Shadow is asking me to create an app. Is Flutter better or Android Studio? Flutter is the newest one, and I believe that it is the easiest one to deploy an app. Android Studio requires more gruesome knowledge of either Kotlin or Java programming. So if you want to do it from scratch and for robust purposes, Android Studio is good. And okay, so Prathamesh is getting an error. Data frame object is not callable. Okay, you are getting it because this you might not have uploaded the data to this. I'll just share the screen again. So yeah, so you might have got error in this section. So either you would have forgot the values to add the values, or the iLock is maybe capital, or some error in this. So if you can make this straight, like if you can do this, then it will, I guess, reduce your error. Okay. All right. Thank you so much, and a very good evening and a very good night. Thank you, Rashika. Bye.
Thank you, Amit. Thank you, everyone, for your patience. We will see you again in the next masterclass. Thank you so much. Have a good day.